Well, a fine Tuesday to you folks out there. Welcome to Takeo Tuesday. I'm John Barba and joined by my colleague Rick Mayo. And we're excited to have you with us today. Whether it's afternoon where you are or where Rick is, it's still pre-dawn, right? Out in out in Nevada. I don't know.
9 a.m.
9 a.m. here in New Hampshire. It's a gorgeous, gorgeous Tuesday early afternoon, and we're psyched to have you with us. Thank you so much for being here on yet another Takeo Tuesday. Today's session is going to be interesting. We're going to take a little bit of a deep dive into some Takeo domestic hot water recirculation solutions,
Right on.
particularly the 006E3. Which we consider that it's becoming the industry workhorse for domestic hot water recirculations because it fits so many residential applications, and its adjustability gives you flexibility and it gives you the ability to install these things without really having to resort to a circuit setter if you know what you're doing. That's what we're going to focus on today.
Right on.
We'll also talk about the smart plug and the proper way to control a domestic hot water recirculation system, as well as some of the dangers of oversizing. And we're going to talk about some of the new stainless steel models out there that might give you some pretty interesting options as well when putting together a domestic hot water recirculation system. So we're really, really psyched to have you with us. And this is going to be a fun and hopefully fruitful hour for y'all. I want to just share some best practices. If anybody's new to Takeo Tuesday, we do have some best practices, some things that you folks can do out there to get the most out of this hour. All right. The first thing is let's pretend. All right. Let's pretend we're not talking over the internet. Let's pretend we're actually in a classroom together and we can see each other. What that means for you is putting the phone aside. Okay, just take this thing and turn it upside down and leave it off or whatever. Put the phone aside. Don't resist the temptation to check Facebook or check your email over the course of the next hour. Let's pretend we're in a classroom together and we can see each other. Treat it like a classroom exercise. That'll help you all stay really, really focused and engaged in what we're talking about. The other way to stay focused and engaged, again, treat this like you would treat a normal classroom exercise and take notes. Take a couple seconds, go grab a pad of paper and a pen and take notes while we're going through this. A lot of folks think, well, if I'm taking notes, I can't really pay attention. I'll miss something. And that can't be further from the truth. Studies show that taking notes is actually a very powerful and beneficial tool for staying focused on the material. And that way also you'll have a written record of what we talked about, okay, today. Now, yeah, you're going to get an email tomorrow at noon or at this exact same time. You're going to get an email that is going to give you a link to the recording of this webinar, and that's cool. You can watch it as many times as you want, but take notes as you go along. That's going to help you stay focused and help you get the most out of this. And the other thing, ask questions. As Albert Einstein says, the smartest people are those who ask questions. Don't be afraid to ask questions. I need you guys to ask questions because, quite frankly, and Rick can verify this, I'm not the most interesting of people. Okay,
Oh,
I can get pretty boring after a while as I drone on and on and on. But ask some questions. Ask questions as they come up to you, and we will address them as they come along. Now,
yep.
how do we ask questions, you may ask? Here's how you ask questions. On your control panel, there's a little section way down at the bottom that says questions/chat. You type in your questions there and hit send, and they'll show up magically before Rick and we can address them. So what I would like you all to do before we get started, and this might be I think this is the third time I've said y'all, isn't it? And
Y'all.
I'm from southern New Hampshire, okay, but I guess that counts. I guess I don't know. So what I'd like you to do, please, if you would, just type in a hi, hello, how are you, some kind of a comment, so I know that you know how to do this, and most importantly, I know that you are hearing me, okay? So if you could type that in for me, I'd appreciate it. Jerry, thank you.
Coming
Gordon,
in.
excellent. Gene, here they come. Brian, all right, rocking and rolling.
Everybody's
We
there.
are
Yep.
ready to roll. All right, so let's get this party started, shall we? All right. The topic, of course, is domestic hot water solutions and a deep dive into some of the products that you can use for domestic hot water recirculation. But just to recap, maybe what we went over 2 weeks ago. Why do we have domestic hot water recirculation? What is the point of all of this? Well, first is to reduce the weight. The weighting, as Tom Petty said, is the hardest part, right? Reduce the weight for hot water. How many of you have stood stark naked out in the shower with your hand, just like we see here, under the shower, waiting for that water to get hot? I'd say that's most of us, all right? Domestic hot water recirculation can reduce that weight, and the weight is the bigger the home, the longer the wait. The way is the way it works. The bigger homes have more hot water fixture units. When you have more hot water fixture units, that's going to require bigger pipe to get the volume of hot water out there. One byproduct of bigger pipe and longer runs, plus federally mandated fixture flow rate regulations, all right, the result of that is lower velocities through the pipe. And when the velocities get lower through the pipe, it just simply takes longer for the water to get there. All right, it's not unusual to have a 2, 3, 4 minute wait. Some of you folks out there, tell us in your own experiences, how long do you folks wait for hot water, provided you don't have a recirc system already, okay? If you do have a recirc system, yeah, go ahead and tell us you do. But if you don't, what kind of waits have you seen? The worst I've ever seen was 4.5, 5 minutes
Wow.
from somebody. I didn't believe it until, you know, she turned on the faucet and said, here, wait, wait, it was 4.5, 5 minutes.
Yeah,
Um,
there's coming in 1 and 3 and yeah.
Yeah. So yeah, it's not unusual for people to wait. Now, older homes, generally speaking, the wait isn't as long simply because just think of the plumbing in an older home. It's stacked, right? You've got the water heater in a central location downstairs, and the bathroom fixture clusters or the kitchen fixture clusters or whatever are kind of all within a few feet of the main stack because we had cast iron drain pipe and you couldn't spread out, economically. So
Yeah.
older homes, the wait isn't really as long unless they have, the types of pipe that clog up over time, the old galvanized pipe, that'll get you. But in reality, it just doesn't. It's a shorter wait because it's a shorter run. Newer homes, more spread out, more fixture units. It just does slow down a little bit. So those lower velocities can create a longer wait. In addition, all right, we want to reduce the waste. Okay. When you're waiting for water to show up, well, that's 2.5 gallons per minute down the drain in the average shower. All right. So if you're waiting for hot water, and what did we have? 3 minutes here. One of the waits was 3 minutes from Dennis, or from Daniel rather. Okay, that's 7.5 gallons of water down the drain, literally down the drain. Now that costs money to get the water. It costs money if you're on public sewage to get rid of the water, and you're making that water heater work a little bit extra. The Department of Energy has determined that simply waiting and wasting for hot water, the average family of four can waste about 12 to 14,000 gallons of water every year, right down the drain, just waiting for the hot water to show up. In terms of dollars and cents, roughly 1/3 the cost of making hot water, meaning the water that you use and the energy that you use to make it, as much as 1/3 of that can actually quite literally go down the drain and be of no use to anybody. So we want to reduce the weight, we want to reduce the waste. We want to do both. So
Yeah.
that's why we look at domestic hot water recirculation. Now, in our last episode, we discussed sizing and we showed you the TACO domestic hot water right size circulator sizing program, which was really pretty cool. And one of the things that we learned is bigger ain't better, is it, Rick?
Nope.
Nope. Big. And Rick, describe to the group some of the dangers of oversizing a domestic hot water recirculation pump.
Well, if you have the older style pipes like copper, and most people do, that's that good old thing, velocity erosion corrosion. If the fluid's moving too quickly through the pipes, it's going to eventually eat it away, kind of like the way we got the Grand Canyon. Even nowadays, over the last 20 years or so, 25 years or so, people are using PEX. Well, PEX, in open potable systems can have some issues. It's not erosion corrosion, but it's oxidation, and there's kind of some recipe stuff that causes that. It's a perfect storm scenario that causes both. So, one pipe can't blame the other for not failing as fast, etc. It happens to all pipes out there.
I think the takeaway here, folks, is hot chlorinated water
Yep.
running at high velocities continuously is the kryptonite for any pipe. All right,
Yep.
that's the
Yep.
kryptonite, and that's going to turn your plumbing system into a sprinkler system, and it can happen in relatively short order. And it's all a function of, and it's ultimately a function of the things that we can control. We can control the size of the pump, all right, by sizing it properly, and we can control the control strategy. So as long as we don't oversize the pump, plug it in and let it run, because that's easy and cheap, we can impact this. We can prevent
Yep.
bad things from happening.
Yeah.
That's bigger ain't better. Or in this case, bigger ain't better. Just no two ways around it.
Yeah.
All righty. Some of the requirements or the limitations
Hey,
for,
John,
yes, sir.
let me interrupt. So far, I can see your beautiful mug, and that's it. You haven't shown us your screen yet.
Oh dear. Oh dear.
Yeah.
Oh dear.
I
And I
thought
had
maybe
such,
you were just preliminarily,
oh
going
my,
up and you were going to, say that you're going to show us our screen. Uh, there you go.
all right. Oh my
Now
God.
is everybody now seeing his screen or no?
And I had such great slides too. Particularly, let's go back. I want to go back because this was my best picture. Bigger ain't better.
Yeah, yeah. Oh
Okay.
my
It doesn't matter how many of these things you've done, folks. If you forget to hit one key button, it all falls apart.
word. I was going to
Oh
say
boy.
something, but I thought, he's just doing a good long lead in.
Oh no,
So,
no, no. Oh, thank you.
okay.
Thank you for that. Everybody needs an editor. Everybody needs someone to watch out for them, folks. So good. Thank you very much. And I apologize, folks. Boy, you missed some great stuff. That's all I can tell you. Anyway, bigger ain't better, as we said. And here are
Right.
some guidelines for your domestic hot water recirculation lines. If we have a dedicated recirc line, all right. If we're talking half inch, and most of the time they're half inch, either half inch copper or half inch PEX because it's easy and cheap, right? Here's the limitation for the recirc portion. When the pump is running, this is the limitation of flow through the recirc portion. If it's half inch copper, we're looking at 1.6 gallons per minute. If you stretch it out to 3 feet per second velocity, you could go up to 2.4. But again, being on the conservative side, we don't know how chlorinated the water is, etc. 1.6 GPM is really a good limitation to work with.
Yep.
If you're dealing with half-inch packs, same thing. 1.4 gallons per minute is a good limitation to work with. Now, this doesn't limit the flow of water when you turn a faucet on. That flow is going to be dependent upon the size of the pipe and the street pressure coming in. And as you can see, there's the limits there are well within the performance requirements of a plumbing system. It's just the recirc portion that we're concerned about. Rick?
Hey, John.
Yeah.
Your third bullet there is talking about PEX, but you actually circled type L copper. So that's another
Oops.
thing on the back. No,
All right.
meaning you pull up that other PEX one, it's going to say something different. Okay.
Yeah, PEX is going to be 1.2 gallons per minute.
Yeah. Okay.
So PEX, yep, okay, thank you again. Everybody needs an editor. PEX is 1.2 gallons per minute. So type L and M copper, 1.6, 1.4. Half-inch PEX, we're going to be looking at 1.2 gallons per minute as your limitation.
Yep.
And that's not necessarily a target. That's your high limit. Okay, that is your high limit. It's not a target. It's a maximum.
Yeah.
It's
Right.
a maximum.
Good point.
All righty. So taking this into account, let's take a look at circulators. All right, let's take a look at what we can do here. And I want to look at the workhorse as we talked about, the Taco 006E3. It's an ECM high efficiency circulator designed specifically for domestic hot water recirculation. That's its primary use. And as you can see, it's kind of set up for domestic hot water recirculation with its union connections. Now, it can be set up to be a pretty powerful circulator, 13 feet ahead max, 11 gallons per minute max, if that's the hydraulics of the system. Um, but it does, like any circulator, it does follow the hydraulics of the system. It respects the hydraulics of the system, as you'll see. Now, as you can also see on that dial, low, medium, and high settings. It's not a click, click, click thing like a 3-speed circulator would be. That dial itself is actually a smooth dial, like almost like a volume dial on your radio. Okay, it's a volume dial. As we turn it to the right, the circulator will go faster. As we turn it to the left, the circulator will go slower. So it's an infinitely adjustable or infinitely variable fixed speed circulator. I can set it up anywhere between min and max. As you can also see, there's little check marks there for both the 003 and 006. If you had if you're taking out, let's say, a Taco standard efficiency old 003 circulator and you wanted to put this in to replace it, well, there's a mark for the 003. And same thing for the mark for the 006. They're marked as reference points. on that adjustable dial. Now you could either take a coin or a screwdriver and insert it in this slot right here, and that'll help you move that dial. So those are the reference points, and that's how you would move the dial. Now, the other thing about this circulator is it is, according to the Hydraulic Institute's energy ratings, it is the most efficient domestic hot water specific circulator on the market, with an energy rating somewhere between, at 162 at high speed, 174 at low speed. The closest domestic hot water specific circulator to this is, I believe, the Grundfos 1555 DHW, which maxes out at 151. So this is considerably more expensive. Not more expensive. It's considerably. I think it's less expensive technically. It's significantly more efficient than any other pump you're going to find out there. That is specific for domestic hot water recirculation. We're going to show you a few other DHW circulators that are actually more efficient than this, but they're not DHW specific. They are stainless steel, which means you can use them, but this is the most efficient DHW specific circulator on the market.
Yeah.
Alrighty. Now, we showed you also last time the DHWR Size Right circulator sizing tool. And if you want to go back and watch that video again, if you were attended, you have the session 2 weeks ago, you have a link to that, but also you can find it via our website or our YouTube channel and see how that Size Right sizing tool works. It's a very easy to use and very simple yet sophisticated and very accurate way to size your DHW circulator. What the end result is, you're going to get something like this. This is a 006 E3 performance curve. And if you put all your information in, including the allowances for pipe for valves and fittings, plus allowances for the head loss through a mixing valve, it will give you both the flow and the head. Now, since we specified 1/2" type M copper, the program says for our recirc line size, the program says, I don't care about anything else. 1.6 GPM is what we're looking at, and we can reduce it if we want to make it lower. But it'll give us 1.6 GPM, and at 1.6 GPM, it calculated 11.35 feet ahead. Now, what the tool does for you is it spits out this pump performance curve, but also note the red dot right here. That red dot is 1.6 GPM at 11.35 feet ahead. Now, that's handy, isn't it? Because what do you think you do with that? What do we do with that, Rick?
Well, you just look at the dial now and you kind of extrapolate between high and maximum, and boy, you're going to get really close.
Yeah, what's it going to do? It's going to look kind of like this, right?
Yeah.
There you see the dial. It's right set to high, but what we would wind up doing is simply turning that to the right a little bit and kind of get it just halfway between high and max. Or when you take it out of the box, actually, it's going to be set to max. So in that case, take it out of the box, you turn it slightly to the left. So we're in between max and high. And in fact, if you left this just at high, if you turned it right to the 006, well, we wouldn't have 1.6 GPM. We'd have something less than that. But again, the 1.6 is a max, it's not a target. So we'd still be fine if we set it just to high right at the 006 setting. And that would be a little bit safer. But here's how you set this thing up without having to buy and mess with a circuit setter, which is kind of the way the industry might be going if we don't look at proper sizing of circulators. All right, how are the questions going out there, Rick? Do we have any questions from the gang?
No,
Yeah.
just nothing specific.
Everybody was wondering where the slides were. All right. Is New Hampshire still a state? Asked Dan Roth. Now, why would you ask that question? Of course it's still a state. It's one of the 50, right, in the Republic. So yes, of course it's still a state, and we still live free or die. That's the way we roll here. All right, some 006 E3 facts and figures. The 006 E3, like all of the Taco 00 series ECM circulators, is equipped with Sure Start unblocking and purging. What does that mean? Well, I'm sure everybody out there has at one point in their careers dealt with a circulator that had a locked rotor. It can happen to black iron oxide or minerals or whatever in the circulator can cause that. If it sits idle for long periods of time, it can cause that circulator to lock up so the impeller doesn't spin. And if that happens and the circulator's told to run and it doesn't, you burn out the motor, the circulator's dead, you got to replace it. Well, this circulator has a little bit of brains to it, meaning if there's power, if the circulator's told to run, the brain inside says, well, I'm told to run. The impeller should be spinning. If the impeller isn't spinning, something's wrong. So what it will do is it will actually go into its unblocking mode, which means it will stop and then it will rattle at full speed, that full 44 watts. It'll go back and forth, okay, like this, back and forth, boom, 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 to try to break whatever's blocking it up.
Mhm.
So it'll go, all right, I'm stuck. I'm going to try to break myself free. I'm still stuck. I'm going to try to break myself free. And it will do this up to 100 times over a 20-minute period. In the wild, what we've seen, 2, maybe 3 cycles, that's usually enough to break out of most situations. Anything that's, that locked rotor kind of thing, the normal causes of a locked rotor. Couple, 3 times, yeah, it's going to get back into normal operating mode, and it'll solve the problem before anybody knows there even is one. If after 20 minutes and 100 cycles it's stuck, there's something physically in there, like a stick or something in there, physically keeping that thing from moving. Then what'll happen is it just says, you know what, I'm not going to burn anything out. I'm going to stop. That status light you see there is going to turn bright red, and that's going to be a signal for someone to come and take a look. All right, so that's the unblocking mode. The air purging mode actually can be very important in domestic hot water applications, especially if the circulator is mounted down low on the return of the water heater. If that gets airbound, if that impeller, that volute gets airbound, that's kind of the same thing as getting blocked, only different. Now the impeller's spinning, but it's freewheeling against nothing. Now the brain knows that's not supposed to happen either. So if that does happen, what the circulator will then do is it'll slow down to almost next to nothing and then bam, shoot up to full speed and slow down and speed up and slow down and speed up, trying to blast the air out of there. And again, it'll do that until the air is gone. So 2
John,
things that can help save that circulator. Yes, Rick.
along that line, you folks, most of our colored details and even some of the black and white ones will always show a purge valve. So imagine coming on the dedicated return line back to the circulator. We want to see isolation. Then there's going to there's going to be a shutoff valve. Then there's going to be a circulator. Then there's going to be a T and a purge valve, and then the other isolation valve. So start, if you're not doing this already, start building that into your jobs. Put that purge, because what John's talking about can be virtually eliminated if you remember to put that purge valve in the right location, purging that entire recirc line out and then turn the pump on. And again, we see this problem, and that's one of the reasons that feature is built in there. But again, just like a good heating system, we have the purge valves where they're supposed to be, and they're there for a reason.
Very good. Very good. Excellent. Excellent. As you can also see, this is a composite casing. So it is plastic. It's a composite casing with 1-inch union connections. No, there's no ability to put an IFC in here because of the composite casting that was done. So there's no way to put an IFC in here. If you need that, it has to be external. But again, those union connections are 1 inch. The circulator itself, when you buy it by itself, does not come with fittings. You would have to buy them separately if you buy the circulator just by itself. But we offer a wide range of fittings. Really, any 1-inch union connection can be used with the circulator. So whatever pipe you are in fact using. And also on the box itself is a cross-reference chart. If you're replacing something else out there, these are the different circulators that it can replace. These are the different circulators that have similar performance. All right, so cross-reference is easy, and the fittings are in fact sold separately with the 003. Now, 006 rather, 006E3. Now, before I get into some of the specific examples of where you can buy how else you can buy the 006E3, I want to talk about controls, because controls are also important. We talked about sizing the circulator properly to save the pipes, to keep the pipes from turning into a sprinkler system. Controls are equally important. Now, most commonly we see 3 levels of control out there that are kind of the cheapest way to go. Number 1 is just a super dumb pump. You plug it in and there's really no control. It just runs 24/7. Well, we know that's a recipe for disaster already, especially if the circulator's oversized. So if it's a simple regular AC circulator plugged into the wall, hey, you're always going to have hot water. That's not going to be a problem. The problem might be that eventually you'll have hot water everywhere, all right, even places you don't want it. So that's the downside of the super simple, super inexpensive, just plug it in and get the hell out of there kind of approach. The next step up from that is a timer, whether it's an analog timer or a digital timer like we show here. Now that's better, but there's some challenges here as well. What do you think some of the challenges are to a timer? Well, first off, somebody's got to set it up, right? We've had folks on our webinars that say, well, I set it up for my customer, or other folks that say, hey, I just give the customer the instructions and let them do it because they know their patterns. Either way's fine. It's not one that's right and wrong. It's just that I don't know about you, but these things aren't that easy to set up. If you've never set one up before, it's kind of the instructions don't really walk you through it. And forget about the digital timer. I'm the guy that had a VCR for decades that was blinking 12. Okay, you know, don't give me this thing, because you need an electrical engineering degree to do your different things every day of the week. It's crazy. The other thing with both of them is specifically the analog one is, hey, you get a power outage. What do? Who goes back and whoever goes back and resets those things? Or you go from daylight, standard time to daylight savings time. Who goes back and resets those? Virtually nobody. One of the things we've seen with these things is they've often been set up to run continuously because I don't know what to do with it. Right?
Yep.
So, and that's, again, recipe for disaster. A third option is an aquastat, which is actually a pretty good option. Timer plus aquastat's actually not that bad, because the aquastat, clip it on to the return side of the pump. Once the water temperature reaches a certain temperature there, doesn't matter what the timer's saying, we're going to shut the pump off. All right, that's a good thing. And if the water temperature drops below, let's say 95, then we'll turn the pump back on again. Now, Rick, where do you think the best place to locate this aquastat actually is?
Well, like you'd mentioned, on the return side of the circulator, but ideally, if you can get it out just at the farthest fixture group, so when it sees the temperature drop there, it brings the circulator on rather than waiting for it to get all the way back to the mechanical room, which is typically where these would be installed.
Yeah, it's a compromise between the most convenient place to put it and the most effective place to put it. The most
Right.
convenient place to put it is just on the inlet side of the circulator because it's right there.
Right.
The most beneficial place to put it, as you said, is going to be at that farthest fixture, because then who cares what the water temperature is between there and the mechanical room, right?
True.
We don't really care. That's the best place to put it. It's also the least convenient place to put it. So if you're adding this and the house is already built, forget it. You can't do it. But a new construction, the best place to put it is way back at that farthest fixture. Now, these are all decent levels of control. Well, no, I'm not even going to say that, because the dumb pump plugged in, terrible way to control it. Timers sound good, but there's a lot of drawbacks there. A timer plus aquastat's not bad. In today's day and age, we sure as heck can do better, and that's where the smart plug comes in. What this will do is it'll take any dumb pump and turn it into at least something a little bit more intelligent. And this is actually a product of ours that won the Innovation Award for product of the, it was best in show for the entire AHR Expo back in 2017, because it had the ability to benefit the widest number of people. And what it is, it's just a go-between between the power source and the pump, and it tells the pump when to run and when not to. All right,
Yep.
Pretty simple, but it's a little bit more intelligent than that, and it'll work with anybody's pump. Doesn't have to be a Taco pump. It'll work with anybody's pump. You plug it into the wall, plug the pump into the smart plug, and then you have some choices. You can let the smart plug do the thinking, or you can control it a little bit more aggressively, but without having to do any actual programming per se. What does that mean? That sounds like a lot of mumbo jumbo. Well, let's talk about it. Again, it's a simple little product. You plug it in to the wall, you plug the pump into this thing. You also, down here, you see a sensor. It comes already wired. So here's a little look at it right here. There's a sensor that comes in the package. You strap that sensor on. That sensor is actually very critical. You strap that sensor on to the domestic hot water supply pipe as it leaves the mechanical room. So it's already, as you can see, it's already wired into the little plug. So you just plug the green thing into the smart plug and strap on the sensor to the supply pipe, leaving the mechanical room. And now we have the ability to control this system. All right, let's talk about
Nice.
how that works. Here you see the smart plug with the sensor, and it's being plugged into the wall. What it does is it learns your domestic hot water usage patterns. It learns how you use domestic hot water. And then it replicates those patterns. It spends the first week of its life learning how you use hot water. And then from then on, it'll replicate your usage patterns while at the same time relearning if anything should change.
Yep.
Right? So it's just kind of cool. So let's say, for the first week, what it's going to do is it's going to be in its pulse mode, its learning mode. So it's going to pulse 5 minutes on, 10 minutes off, 24/7. So you'll always have hot water no matter when you turn it on. But it's also looking for what we call a hot water event, which we'll describe later. If it senses an event, let's say 6 in the morning on Monday, you get up to take a shower, it says, hey, 6 in the morning on Monday, somebody got up to take a shower. I'm going to remember that. And then a week later, that following week, it's out of pulse mode, meaning it's off. It knows someone's going to take a shower at 6 in the morning. So what does it do? At 5 in the morning, it's going to start pulsing, 5 minutes on, 10 minutes off, 5 minutes on, 10 minutes off, to get that hot water line primed with hot water. So that when you get up at 6 or 5 of 6 or 10 of 6 or 10 after 6 or whenever to take a shower, bam, hot water's there. And it does that automatically. And it'll do that. It'll have a Tuesday function. It'll have a Wednesday function. It'll have a Thursday function. And it learns all of the events, the major hot water events during each day, and it'll replicate them. And if things changes, it'll change along with it. So
Cool.
It learns your domestic hot water usage patterns. And again, 5 minutes on, 10 minutes off. So it doesn't run continuously. It'll run once it's, as we said, if it knows you take a shower at 6, it'll start pulsing at 5. And what it does, it'll pulse for a 2-hour window between 5 and 7. So 5 minutes on, 10 minutes off, 5 minutes on, 10 minutes off, for a total of 20 minutes each hour. So over that 2-hour period, it'll run for about 40 minutes, all right? Non-continuously, but it'll run for about 40 minutes to keep the hot water line primed. And then after that, it goes off, all right? So the pump doesn't need to run after that point. Again, there's no programming, no dip switches involved. It does all this learning internally. And it also has what we call an optional pulse mode. Now, what does that mean? Well, let's say the way things are now, people working from home, a lot of times folks do not have any kind of consistent domestic hot water usage patterns. Or let's say it's a light commercial application where there's no consistent pattern. It's just people could be using hot water any time of the day or night. Well, in the pulse mode, it just simply goes 5 minutes on, 10 minutes off, 24/7. Okay. So again, it's not quite as efficient as the learning mode, but if the learning mode simply isn't appropriate for the application, you know what? Instead of running it continuously, instead of running 60 minutes every hour, we're going to run 20 minutes every hour, and we're going to break it up. We're going to stagger it so we don't destroy the pipes in short order. So there's your optional pulse mode, which is, again, a fail-safe. If you want to make sure, I always want to have hot water. I don't care what time of day or night. You put it in pulse mode, and you can do it safely and effectively. Size the pump right, control it right. We won't have an issue with the pipes.
Right on.
All righty. Power outages. What it does is it resets after a power outage. If there's a power outage for any length of time, it goes back into its learning mode. It'll go back into a week-long pulse mode, and it'll relearn. All right. So you don't have to, there's no reprogramming or no, oh God, what do I do now? I don't have to push any buttons or anything. It just does that all automatically after a power outage. And the nice thing about that 2-hour window I just told you about, it'll readjust when we go from standard to savings and savings to standard time, right? Because you've got that 1 hour either side. So it'll automatically readjust based on your time changes. And also, 2 important things, vacation and exercise mode. So if you go on a vacation, all right, let's say you leave. If it senses no hot water usage or no hot water event for 36 hours, it basically shuts off. It says, I'm done. I'm not gonna make this thing work because nobody's using any hot water. Then when you come back and you have an event, it goes back into its learning mode. All right, it'll go right back into its learning mode for you. So you get that, 5 on, 10 off, 24/7 for a week, and it'll relearn. Or if it's in pulse mode, it'll go right back into pulse mode. While it's in vacation mode, it also goes into an exercise mode. So we don't leave the water stagnant in the pipe. So once a week or so, it'll actually run that pump for a few seconds to keep flushing that line out so we don't have stagnant water in there. So those are 2 features or functions that are built into the smart plug. And here you can see it's set up in two different applications, one with a mixed valve, one without. And again, we see the sensor, which is, even if you're in pulse mode, you have to have the sensor on the supply pipe, leaving the water heater, leaving the mechanical room. And here with the mixed valve, it's on the mixed portion of the pipe going out to the plumbing system. So,
Hey, John.
Yes, sir.
Go ahead and show them those hose bibs at those locations I was referring to so they can see. I didn't know you were going to have this slide, so it shows exactly what I was talking
Right here.
about.
Yep.
That
Here we got
hose bib.
check valve and a hose bib right here,
Hose
and a
bib right
shutoff
there.
valve for purging. There you go.
Yep.
Right there, and also right here.
Well,
Check valve
down, right
and hose
there.
bib.
Yep.
Very good. Very good. Very good. Alrighty. Now that pulse operation, again, the first week it's in service, we have 5 on, 10 off, 5 on, 10 off, 5 on, 10 off, 24/7. So no matter what time of day you might have you get up, take a shower, or you do use the hot water is always going to be there. 5 on, 10 off, 5 on, 10 off. So we've got that hot water line primed the entire first week as we're learning, okay, as we're learning. So as it's learned, after that first week is done, it turns the circulator off. But again, let's say it's 6 a.m., we were going to get up and take a shower that Monday. So what's going to happen is at 7 a.m., let's say 7 a.m., we were going to take a shower. In this example, what it's going to do, it's going to turn the pump on at 6 a.m. and do that 5 on, 10 off, 5 on, 10 off until 8 a.m. So what'll happen is the water in the pipe will, over that first few minutes, will increase up until we get to the hot water at the fixture. And then it'll stay there, 5 on, 10 off, 5 on, 10 off for that 2-hour period. Then it'll shut off. The water temperature in the pipe will drop down to whatever ambient is. And let's say we have another event at noon, okay? Well, then at noon, or let's say 1 o'clock, there's an event at 1 o'clock. The smart plug tells the circulator to turn on at noon. We get the hot water line primed, it stays up here, and then at 2, it stops pumping the water heater. The water starts to drop temperature starts to drop in the pipe, and so on. So again, that's kind of the operation of this package. All right. And
John?
Yes, sir.
Another thing, and you might be going to say this, so my apologies if I'm butting in, but a lot of people think that during those off times, the savings of the circulator not running is all we're talking about, but it's not, right? The circulator not running is one thing that's eating up a little bit of electricity, and I mean a little bit, but what else is not happening when that circulator is not running is the point I wanted to make. And you might be making that later, so I thought I'd just throw that out there for
No, I think you bring up an excellent point. What is it, Rick, that won't be running at that time?
That water heater won't be banging on and off like it would normally do. And we're talking even a tank style. You start bringing cold water back in the bottom of that water heater, you're gonna that aquastat's gonna see that and it's gonna fire again. So we're reducing the amount of firing and cycling of that water heater, or regardless of the piece of equipment.
Right. And especially, and we talk about tankless as well. With tankless, really, the smart plug and anything with a timer is not a great idea for a tankless, because you only want a tankless water heater to run when a hot water use is imminent.
Yeah.
Right. That's why so many of these tanklesses now have something built into them, a circulator and a control strategy built into them for that purpose, because they found that people were putting timers on these things and they were short cycling. The circulator would be running even when there was no use for domestic hot water. So that water heater would be going bang, 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 on and off, on and off, on and off, and just basically destroying things and voiding the warranty. So you're seeing this trend now. The tankless water heater manufacturers have their own built-in domestic hot water recirculation circulator and control strategy, which is really probably the best way to go. Otherwise, you want an on-demand type system like the Taco Genie, which we're not talking about in this particular session, but we can in the future. Cool. All righty, some options with the 006E3 and Smart Plug. This is the Smart Plus E package. So it's just simply the 006E3 packaged with the Smart Plug. all right, packaged with the smart plug, and does not come with the fittings either. But you get the fittings, you get this package, and if you have a recirc line, bam, this is a great way to go because you have the flexibility and adjustability of the 006E3, so you can set it up to just the right speed for the size of the system, and watch that 1.6 or 1.4 or 1.2 gallons per minute. All right, so you've got that. And then you have the smart plug for the intelligent control. So you've got yourself covered in both directions. And this comes in one package, if you will.
And you do get the line cord with that. The
Yes.
pictures don't show it, but you get a line cord version of that pump.
Right. It comes with the line cord already built in. Absolutely. Also with the line cord, now we get into fittings and hoses and stuff. This is the HotLink Plus E kit for those jobs where you don't have a domestic hot water recirc line installed. So this is retrofit, right? There's no chance to run a recirc line, so you have to come up with another solution using the HotLink Plus E. And the HotLink Plus E uses the cold water line as your recirc line, with this crossover valve, this black crossover valve that is installed under the sink on the farthest fixture away. So when there's no recirc line, you use the 006E3 with the HotLink crossover valve shown here. Comes with hoses, comes with power cord, comes with your fittings. And you use that cold water line as the hot water recirc line. Okay, and here you can see the crossover valve mounted under a vanity, okay, which is where you'd put it in your farthest fixture group away. Now, there's got to be a question out there, right? Someone has to ask the question, whether it's homeowners ask the question, folks in the trades, we all ask the question. Wait a minute, what the hell's going on here? We're using the cold water line as our recirc line. What's the big concern? You folks are out there. I know you can hear me. I know we haven't had a question popped in a while. What's the concern here? If we're going to use that cold water line as our hot water recirc line, what, my friends, is the concern? What's the obvious question?
There's at least a couple. At least a couple. So,
at least a couple.
Send us
One's wicked obvious. So type that in if you got it. I'd like to hear from you. What is the one thing we're worried about here when we do this? Well, right, Matthew, exactly. Won't the cold line get hot? Won't the cold line get hot? Well, we sure as heck hope not. And because as a company, we're not irretrievably dumb, we've actually tried to address that in as an effective way as possible. There are other crossover valves out there that actually you can almost set your clock by them or watch by them that they're going to fail within 12 to 18 months. And you very well may get a lot of hot water in the cold water line because of a couple of reasons. A, the valve isn't very reliable, and B, it's a very slow acting valve. What we've done here is we've created a very fast acting and very reliable and field serviceable valve. All right. What we have to prevent this from happening is right over here. If you look to the right of your screen, the cartridge that comes with this, that's part of the package, has a thermal sensor disc. It's a bimetal disc sitting right there on the end of that cartridge. And what the bimetal disc does is when it senses that when the water's cold, all right, it stays open, and it allows, when the circulator runs, it allows for flow to go through the valve, and we bring the hot water there. Once the hot water arrives, and remember, the hot water arrives not in a slow, gradual increase. It's cool, it's tepid, it gets a little warmer, then bang, almost like a slug, the hot water's there because the pump just turned on, right? It comes in a slug. As soon as that slug of hot water gets there, the disc will actually snap closed. It literally acts that quickly. It'll snap closed and shut off the crossover. So there's no more crossover. We won't get any more hot water into the cold water line. How much actually does get over there? In reality, very, very little. What we have actually seen is once that valve closes, if you go to turn the cold water faucet on, by the time you turn that cold water faucet on and get your hands underneath, oftentimes that's it. We're done. The hot water's been pretty much flushed out. You don't get very much there, maybe a cup or two on the other side. so we don't fill up the hot water, the cold water line of hot water? It's a very important question. It's an excellent question. It's something you should be concerned about when you select one of these. And fortunately, we've had tremendous success with the hot link valve. And again,
Yep.
the cartridge is actually, it's hand tight, and it should only ever be hand tight.
Right.
Don't crank the sucker down with a wrench or anything. Hand tight is tight enough. And you can see right here is the thermal sensor disc. I hope you can see that okay. There's the thermal sensor disc, and it'll just snap from concave to convex and close off the flow when the hot water arrives. So that's again the fail safe there. That means you don't have to worry about it. So when the hot water's there, bang, snaps shut. Now
John,
yes, sir.
um, if just to throw something out for the service guys, if you ever get a call and you're going out and working on somebody else's work or something, and they say this valve is knocking, making a little bit of noise, that's the first thing to check, is what John just mentioned, that somebody's probably tightened that thing up with a wrench. And what it'll do is it kind of smashes that snap disc that John was talking about, and doesn't allow it to fully go from convex to concave or vice versa. So just you guys doing service work, if you ever hear that of those things knocking, that's the first thing to look at, is loosen that thing up and make sure it's only hand tight.
Right. And what do we mean by hand tight? Pretty simple. Again, you put it in, as we show here. It's really loose. Now you're gonna hit some resistance here. Just keep going through the resistance until you hit a hard stop right here. Now, right now I
Right there.
can't move it with
Yeah.
the same level of effort. That's tight enough. It's watertight. It's tight enough, and we're good.
Yeah.
Right? Now, the flow rate through this valve is rated at 0.33 GPM. 0.33 GPM. That's the limit. When you go through the size right program and you pick this, bam, 0.33 GPM is what you have. All right. And that changes how you set up the 006E3. Let's take a look. All right. Here we can see a system that we designed. It had maybe 100 feet of pipe out to that farthest fixture, 120 feet of pipe out to that farthest fixture, 1 inch to 3/4 to 1/2 inch. We're not worried about the line coming back because the water's not going back, right? So we wind up with a completely different sizing scheme here. So in this example, we had 0.33 GPM with less than 1/2 foot of head. Now here you see the requirement. Well, where are we going to set this sucker? Got to be minimum speed, right? There's no reason to set it anywhere else. So you turn this dial all the way back to minimum, and that's going to be
Nice.
more than enough, right?
Yeah.
And now we're dealing with about a 5-watt pump, okay? A 4 to 5 watt pump. And now you're dealing with efficiencies up in the 170, efficiency rating up in the 172 range. And that's going to be plenty. That's going to be plenty. Right? And again, with that 5 minutes on, 10 minutes off, 5 minutes on, 10 minutes off cycle, and you've got that 2-hour window, okay, it may take a couple of cycles at that flow rate to get the hot water there, but you've got that 2-hour window, which is why it's built in.
John,
Yes, sir.
you might be covering this, but Kurt has a good question. He just wants to know, can you use multiple hot links with a single pump?
Who asked that?
Kurt.
Kirk?
Kirk.
Kirk?
Kirk with a K.
Kirk with a K? Kirk? In the world of presentations, there are 3 types of questions. There are 3 types of questions. There's a good question, and that's any question. Good question is any question. Any question is a good question. Then there are great questions. And great questions are questions that you have a slide later on in the presentation that actually addresses that particular question. And then, Kirk, there are brilliant questions. And brilliant questions are rare, but they are brilliant. And you, my friend, just asked a brilliant question, because a brilliant question is addressed by the very next click of the mouse. So yes, you can use multiples. We've actually tested this to up to six valves in a system. So if you got a fixture, bunch of fixture groups on the left-hand side of the water heater and a bunch of fixture groups on the right-hand side of the water heater, sure, you can certainly use multiple hot link valves. You don't have to upsize the pipe, because it's kind of like sizing a pump for zone valve application. It's the same thing, right? It's not cumulative pressure loss. It's just, whatever the worst case one is whatever the worst case one is. So yeah, you can do up to six in your different fixture groups. Absolutely. Brilliant question, my man. Brilliant question. Real quick, I want to make a case for pipe insulation because that 5 minutes on, 10 minutes off at 0.33 GPM does bring up the issue of pipe insulation. Now, pipe insulation is always a good idea for your hot water pipes. It's not just to keep them from
Absolutely.
freezing, although that's a good thing, but it does help speed up the hot water delivery. It reduces the heat loss, the line loss
Yeah.
of the pipe as we're delivering hot water. Now, by how much? It's going to show you something pretty interesting here. So it speeds up the hot water delivery. It increases the max temperature also at the water at the fixtures to a certain degree. It also keeps pipes hot for consecutive uses. So again, if you have a shower at 6 and then another shower at 6:45, there's a good chance that the insulated pipes have kept that hot water line nice and hot over that time. So it keeps the pipes hot for consecutive uses, obviously reduces the overall line loss of the pipe, which is the point, and hey, it saves energy, which everybody wants to save energy. So a great case for pipe insulation. And here's what it might look like graphically. So
Yeah.
here's a typical hot water event, okay, with uninsulated pipe, It takes a while. We have the ambient temperature here, and then we have the time it takes for delivery. So the y-axis here is temperature. The x-axis down at the bottom is time. So delivery, get that hot water hot enough at the fixture. All right, that takes a little bit of time. We have the use, so that stays pretty constant, right? And then when the use is over, you have this slow ramp down cool down time. All right, that's uninsulated pipe. Now, if we add insulation to the equation, you can see a couple of things. Number one, that the ramp up curve is steepened, so it's quicker. We get up to
Yep.
that useful temperature quicker. We have the ability to have a higher useful hot water temperature because we haven't lost that anything going out there. And then the ramp down time is a lot longer. So if
Absolutely.
someone's going to take a shower, let's say at this point in time where my cursor is, they don't have to wait for any hot water, it's still there. So if you combine with the Hotlink Plus E, 0.33 GPM, all right, 5 minutes on, 10 minutes off with the smart plug, with insulated pipe going to at least as far as that farthest fixture, obviously, you're going to see a great enhancement of the Hotlink Plus E's performance. It's going to work a lot better, a lot quicker, and a lot faster, and a lot more efficiently. Other than that, why do it, right? Sorry, inner wise guy coming out. All right. Very good. Okay. And lastly, I would like to share with you some new DHW options we have just come out with over the course of the last couple of months, and they should be getting out into the marketplace any time now. And these are our other ECM solutions, the 007E, 0015E3, and the 0018E, all available in stainless steel volutes now for domestic hot water recirculation options. And as you can see, they come in both flanged with our 4-way universal flange, as well as union connection, so you can get them either way. All right, for stainless steel applications. Now, the 007E is about as simple as it gets. It's an ECM circulator. It's a variable speed circulator, but there's only one setting. So it's a 10-foot ahead constant pressure setting. If you were to use this in a residential application just as is with a smart plug, you might find that that 5 minutes on, 10 minutes off thing is going to save you. Okay, it's going to save you, but you might find that you might need a circuit setter to get down to that 1.6 gallons per minute limit, depending upon the hydraulics of the system. Same thing for the 0015E3. It's 3 settings. It's low, medium, and high. So low is 5 foot ahead constant pressure. Medium is 10 foot ahead constant pressure. And high is full speed, fixed speed. So you'd have to see, again, looking at the charts that the DHW SizeRight program prints out for you, you'd have to see where the hydraulics land and what setting you might need. The 0018E is the one I want to focus on because the 0018E, as its hydronic heating brother, has Bluetooth connectivity to an app, right? And you can connect to this app, and opens up a world of diagnostics and of programming. The part that's going to be most useful to you for the 0018E is if you really want 1.6 gallons per minute, if that's how you want to set this up, You can do this again without a circuit, without getting involved with a circuit setter. Again, going to be make it a little simpler, a little easier, and verifiable, because you can also print out the performance, the way you set it up, and say, hey, I set this thing up at 1.6. Somebody changed it, but this is how I left it. All right. What you can do when you connect this circulator to your phone or to an iPad or any kind of any device, Bluetooth device, you have the ability to manually program it using the device. And here's what it would look like. You use the blue setting, the min max setting, again, infinitely adjustable, fixed speed. So you see the entire blue wedge is your operating mode here, right? That's the entire blue wedge. Now down at the bottom of the screen here, you see 6.6 GPM, 9.8 feet ahead, 24 watts, and it gives you the RPM. And that's what that does, is that's a real-time readout. If you take a look up here, you see this little ball here, that's on a slider. So if you take your finger and you put it on that ball, you can move that thing to the left or the right just using your finger. And as you slide this thing down, let's say we want to get it down to that, minimum setting, what you would do, like say you were using it with the 0.33 and the hot link plus valve, you wanted to get down to 0.33 GPM. What you do is you just take that thing and go all the way down, and then that's the minimum setting. More importantly, though, let's say you wanted to make sure you were at 1.6 gallons per minute for a recirc setup. Well, what you would do is you'd slide that blue dot back and forth until this dot right here, which is your actual service point, got to 1.6 GPM. And the head would be whatever the head actually is at 1.6 GPM. It's giving you a readout of the hydraulics of the system. You'll know you're there when this guy down at the bottom reads 1.6 GPM or reasonably close to it.
Yep.
Okay. The head will read out what it is. The wattage will read out what it is. But now that is verifiable. And if you go into the diagnostics here or into the settings up here on the upper left, you'll see you'll be able to verify the settings. Hey, last time I was here, this is how I set this thing up. It was at 1.6 or 1.4 or whatever it happened to be. So that gives you the ability, without a circuit setter, to actually dial that sucker into the exact spot that you need it. And that's kind of a new level of control and a new level of programming diagnostics that really, there's nothing else like that out there in the marketplace. You can set that sucker up exactly where you need it.
Beauty.
So that's the cool thing about the 0018E in stainless steel. It gives you that capability. So, and also, again, if it's a flange setup, you can put it in flange. If you wanted a union connection, you could do it in the union connection.
Hey, John, I might have missed this, but when John was introducing those new stainless steel circulators, those come with the IFC in the box, and you snap them in there.
Right. These are, because they're stainless steel, they are set up with you can get them with IFCs. Absolutely. Absolutely. All righty. I want to open this up for questions back to you folks again. Any questions you have on this? Was this a useful presentation for you? Again, we wanted to do that deep dive into the specific products and how to set them up and how to make them work for you. Again, the thing to remember is this 1.6, 1.4, 1.2 gallons per minute limitations, folks, that's going to be part of your lives if it isn't already, because lots and lots of failures are happening out there with PEX and with copper. And the way the world is, everybody's doing this. Who's responsible? What you don't want is it to be you, right? You don't want it to be responsible. It's why we train that's why we have the Size Right program. It's why we train on this topic. So we want to make sure you're covered and you know what the limitations are and you know how to set up the circulators so you will achieve those limitations, so you won't surpass those limitations. So again, the 006E3, really, really great way to go in terms of making sure you have that ability to set it up, verifying it with the Size Right program. You can set that thing up just so. The 0018E, you want visual verification, you want installed verification of the performance of this circulator. Well, bam, there's nothing else out there that's going to give you that. So nice. That's very, very useful.
Hey, John.
Yes, sir.
If they want a copy of that maximum velocity sheet, that's a handout we can sure put on there or send them later or whatever. So I didn't know if we'd put it on there or not?
Oh, I'm sorry, I did not include that in the handout, so we will we'll have to make sure. What we'll do is we'll put a link to that in the follow-up email that's going out tomorrow, so you'll have
Perfect.
that available to you.
Perfect.
Very
We got
good,
some
very
questions
good.
coming in.
All right.
Kurt, any concern about flow reduction from pressure drop on the hot water supply line at the tank when hot water system for large house, such as two shows running at the same time? Two showers, I assume. Any concern about flow reduction from the pressure drop in the hot water supply line? Kirk, are you talking about having the pump on the supply side going out? Yes. Okay. So again, we don't have CVs listed for these pumps because they don't impart friction in the normal application. They apply mechanical energy or pressure differential. But yes, the answer is yes, but we just can't tell you what it is unless John, you want to take a stab at it.
Oh, in terms of the flow restriction through the pump itself,
Yeah, through the
that's gonna I'd have to look up what it is, but is it a major concern? Not that I've seen. Again, because again the bigger player here is your pipe sizing. What you have is like it's momentary pressure loss more than flow restriction. Kind of like if you put your finger over a hose, right? If you put your thumb over a hose and it's just over a fraction of the hose, well, the velocity does speed up, but the flow rate's still going to be about the same, right? If you put it over 3/4 of the hose, well, yeah, the velocity goes up, but the flow rate does go down. But it's like putting just your finger over just a little bit of the hose. A similar thing that a lot of people talk about, with insert fittings, right?
Yeah.
Let's say a Propex style insert fitting where you cold expand the pipe, put an insert fitting in there. The fitting itself is the fitting itself. The idea that fitting itself is smaller than the pipe. Well, does that mean? Yeah, I've had people say, "Well, that just turns a 1/2 inch pipe into a 3/8 inch pipe." That's BS. That's stupid. That's not what it does. It's just momentary pressure loss at that point. You return to full flow within a second or two after that, within less than a foot after that pipe. So flow reduction, not so much. Would there be a minute amount of pressure loss? Yeah, maybe about the same as a couple of fittings, again, in that respect. Just remember, the circulator's not providing flow to the fixtures. All right, that's the
Yeah.
street pressure. We've had that question often. This is, well, wait a minute, that 1.6 GPM or 3 feet per second, 2 feet per second. That's not enough flow to run two showers at the same time. The pump's not doing that. That's not the point of the pump. It's not a booster pump. It's not a delivery pump. If you didn't have the circulator there, you'd get pretty much the same performance in your system.
I'd like to add something, John. If I think Kirk, just realize that I think what you're talking about is when the circulator is installed on the hot water line going out to the fixtures. You don't have to put it there.
Right.
You can put it on the dedicated return line coming back, and it'll never impart any additional pressure drop. So some people let you go in the bottom of the tank. In a lot of areas, they don't. Like California is where I'm not in California, but I'm real close. Some of them will never let you pull that drain out of the bottom of the tank, put a T in there, and put water in there. As far as I'm concerned, that's a great location. I think their worry is sediment might block it off, but you got that much sediment in the bottom of the water here, you want to know about it. But
there's other
so I
problems.
just want, and there's drawings. We got a nice little booklet of colored drawings that show several different ways to pipe this stuff up. So if you want those, we can get you copies of that as well.
Very good, very good. But yeah, I think again, it's important to remember the purpose of domestic hot water recirculation isn't to deliver amounts of hot water to fixtures. That's the pipe sizing and that's the street pressure. Its purpose is to keep the hot water line primed. That's all it does. We're not moving volume, we're moving heat, we're moving warmth. All right, moving temperature might be the best way to put it. We want to keep the hot water line primed with hot water. That's
Yep.
all it's trying to do. It's not a delivery pump at all. So we've had that quite. I mean, I've had engineers tell me,
Yep.
wow, that pump has to be sized to deliver the hot water, the total load for all the fixture units combined. And he's got this base mounted monster for his DHW recirc pump. And I go, okay, you sign off on it, your baby, but boy, oh boy, you're going to have to explain a sprinkler system in about 6 to 10 months. I mean, it's just
And buying pumps as
crazy.
they go out, because that's not a good place to run that pump either. So
Exactly.
he's got a multitude of problems if he's doing that. So
Yeah, there you go. There you go. All righty, cool, cool. Here we go. We're designing new homes, mostly tankless water heaters, sometime multiple tankless on big homes. Yep.
yeah,
That's a kind of a growing thing, and I think you're, as we said earlier, Bill, you're probably seeing that the tankless manufacturers, because of misapplications, they're kind of taking control of their own DHW recirc by and large.
yeah,
It's not universal, but they're taking control of that internally, and I think they should, because timers and tankless are they're just it's a deadly combination. I mean, that's not forget about causing the sprinkler system to happen out there in the home. We're gonna burn out all the moving parts of that water heater and void the warranty.
yeah,
So yeah, you want to make sure the tankless that you choose follow their guidelines and their own internal control strategies for domestic hot water recirculation. That's really the best way to go there. And again, they're taking control of it because they need to. Cool. All righty. Excellent. Folks, really appreciate the gift of your time this beautiful Tuesday. I hope everything's cool where you are, and as we get into fall, if you're in the heating areas, well, heating season is almost upon us, so you'll be out there doing a lot of heating systems. So that's going to be keep everybody pretty busy as we get
snowing in
ready for the cold
Wasilla.
weather. It's snowing in Wasilla. That
Yeah.
sounds like a country song.
Well,
It,
that's my old home for those who know. But
oh, we got,
hey,
and
Eugene's in Juneau.
it's
Yeah.
50 in Juneau. How about that? All right,
Yeah.
Eugene, man, it's 50 in Juneau. It's going to be fit. It's gotten down into the 50s here at night, the last few nights here in New Hampshire, but we're using the 70s during the day. I don't think we're going to hit 80 anymore. But boy, it's a beautiful time of year, and boy, when the leaves turn in the next few weeks, it's going to be crazy in New Hampshire. I'll tell you what.
Beauty.
Leaf
Yeah.
peepers.
Yeah.
All righty, Rick. Pleasure as always working with you. Thank
Johnny,
you so much.
you did a good job, everybody. I'm sure you agree that you laid it out very nicely. And boy, and if you folks aren't asking questions, that's your fault.
See, that goes back to the part of the presentation that was blind. I had a great quote in there, man. I'm telling you, the first part of this presentation was so visual, all right, because I went out of
Okay.
my way to make it visual and I messed
We'll
up.
have to do it again, and we will.
All right. Hey, all right, folks. Hey, Rick, thank you so much. Everybody out there, thank you for the gift of your time, and we will see you again soon on Takeout Tuesday. Take care, everybody.